Welcome to the video lecture on project planning and scheduling. In this video lecture, we'll be seeing work breakdown structure, Gantt or bar chart and its limitations, network analysis, and in that we'll be seeing critical path method, which will be on activity on arrow method. Now let us start with it. So what is work breakdown structure? So the definition according to the PMBOK, that is according to the project management body of knowledge, it is an deliverable oriented hierarchical decomposition of the work to be executed by the project team to accomplish the project objectives and create the required deliverables. So according to PMBOK, this was the definition, PMBOK, this was the definition. Now just understand what is the actual meaning of the work breakdown structure. So whenever we need to build a project, so we must start with the foundation. So the foundation of the project is the work breakdown structure. Now this is a typical structure of an work breakdown structure. So a major problem in project planning is determining how long the task will take and what it will cost to do them. Inaccurate estimates are a leading cause of project failures, and missed cost targets are common cause and stress and recrimination in project management. The most useful tool for accomplishing all of these tasks is the work breakdown structure. The idea behind the work breakdown structure is simple. You can divide or subdivide a complicated task into smaller tasks until you reach a level that cannot be further subdivided. At that point, it is usually easier to estimate how long the small task will take and how much it will cost to perform than it would have been to estimate these factors for higher levels. That doesn't mean that a work breakdown structure shows the sequence in which the work is performed. Such sequencing is determined when a schedule is being developed, and that is being determined according to the various logical sequence. Now, the work breakdown structure is an identification of all the tasks that must be performed in order to achieve the project objectives. The typical work breakdown structure has 3 to 6 levels, and these can be named as shown in the figure. So in this figure, we can see the various levels of an work breakdown structure. So we can see the program level. This is the program level. Then the main, that is the project level. Then it can be task level, then subtask level, then work package, and finally the activity level. Okay. So it is of course that possible to have a project a lot more levels than this. So 20 levels is considered to be the uppermost limit or the upper limit, and that is for a huge project. So note that the level one, this is that level one is called the program level. The difference between the program level and this project level is just of 1 degree. The work breakdown structure should always be developed before the schedule is being worked out, but without trying to identify the sequence of the activities. The reason is quite simple. Until everyone has agreed that all tasks have been identified, it is misleading to develop a schedule. So you cannot be sure that the critical path identified by a partial schedule will be the same for the full schedule also. So a work breakdown structure does not have to be symmetrical. All paths do not have to go down the same level. Now, what is the purpose of developing this work breakdown structure? So there are mainly 3 reasons for developing the work breakdown structure, or there are 3 purposes. So first is that it helps more accurately and specifically to define and organize the scope of the total project. So it is very important to define the scope of the project and to know correctly the scope of the project. The second reason is that it helps with assigning the responsibilities to the persons resource allocation, monitoring the project, and controlling the project. Finally, the third reason is that it allows you to double check all the deliverables specified with the stakeholders and make sure that there is nothing missing or overlapping in it. So these are the purpose of the work breakdown structure. So factors influencing the work breakdown structure. So these are the various factors. The first factor is the project life cycle used, the project life cycle phases, number of deliverables, complexity of the project, type of the project, team size and resources, and the finally risk involved in the project. So these are the factors which are influencing the work breakdown structure. Now, various work breakdown levels. The first level we can tell this is the highest level or the topmost level of the work breakdown structure, and is generally referred to as the level 1 of the work breakdown structure. So this will be a single task, which is the project or the project name. So then the next level comes the level 2, that is this can be based on the project phase, the product of the project or the organizational departments. If the level 2 is based on a project, tasks are engineering, manufacturing, construction, and testing and commissioning. So what is the relationship between each level? So there is a parent-child relationship between these levels. So each level of the work breakdown structure has a parent-child relationship. The parent task in the work breakdown structure will finish only after all its children tasks are completed. So how do we start the work breakdown structure? So first of all, we need to gather all the relevant information. So this information includes a statement of work of the project, task analysis, schedule of the deliverables of the project, milestones which are to be achieved, project scope statement, problem analysis, design documentation, or any other relevant documentation. So this is the first step of the work breakdown structure. So how to start with it? So start with the first level that represents the whole level, and this should be numbered as 1. Then the second level will be or it will vary depending on whether the work breakdown structure is a product based or process based. For example, whatever is an tool which is being developed, that can be a product based, whereas the construction etc can be a process based. So a product based work breakdown structure is broken into series of deliverables in the second level. These deliverables should capture 100% of the total project scope. Nothing should be missed in this. The next is the a process based work breakdown structure is broken down into series of phases in the second level. In each phase may or may not have a deliverable, but all the major project phases should be included in it. An example of the process based work breakdown structure might be to use the stages of ADDIE, that is the analysis, design, development, implementation, and evaluation, as the major 5 phases of the second level, that is analysis, design, development, implementation, and evaluation over here. So this is the second phase. So for further purposes of our example, we'll use a product-based work breakdown structure. So development of a new program can be broken down into these stages, such as the needs analysis, the curriculum proposal, course development plan, accreditation package, implementation, and the evaluation plan. So at this point, we enter a stage of the process called decomposition after this. Okay. So in this, so to further break the work down into smaller and more manageable chunks of work, which are known as the work packages. So there will be question that how small the work packages should be. So what will be the number of hours of the work packages? What should be the quantity of the work packages? So there is a general rule that we might use, that is called as the 880 rule. So no work package. So according to this rule, no work package should be less than 8 hours of work or more than 80 hours of work. So generally this type of rule can be used for defining the work packages in the work breakdown structure. So the process of decomposition can be done by an individual or by the whole team. It all depends on what makes sense for your project. So still, two minds are usually better than one. So you can take some advice from the other team members too. And what will be the lowest level of this? So the lowest level of each activity on work breakdown structure should be an individual task. So this task should be possible to complete by an individual or a team within a reasonable defined period of time. For example, delegating the task of drawing up action list should or could be completed by an individual within a defined period of time, such as one afternoon. This is a typical work breakdown structure of a construction project. So first of all, we can name it as the construction project or overall project, and it can be divided into these subtasks, that is engineering, procurement, construction. Then again, it can be further divided into the various work packages, etc. So this is a typical example of an work breakdown structure of an construction project. So after this, we'll be starting with the Gantt chart or the bar chart. So this chart was formulated for providing graphical schedule for planning and controlling of the work and recording the progress, towards stage of project. A Gantt chart is a typical type of bar chart that illustrates a project schedule. So it was being introduced by the Henry chart. It was introduced by Henry chart. So you can see that there are various bar charts in this. There are various activities on the graph we can see over here. So Gantt charts have become a common technique for representing the phases and activities of project work breakdown structure. So how to construct a Gantt chart? So first of all, we need to make a list of activities. So first, make a list of everything that you plan to do in a project. Take your methodology and turn it into a step-by-step plan. Break down your project into number of activities. For example, if you're doing a research work, so this can be the various steps. Okay, so first one is the defining the research question. Then it can be literature review. Then we can revisit the research question, make research design, sample design, collection of data analysis, and interpret the solution, etc. So constructing a Gantt chart. How to construct a Gantt chart? This is the second step. We need to estimate the time required. For each item on your list, estimate how long it will take you to do that thing. So here is an example of this. So first can be the defining the research question. We can take that for 1 week. Second is the literature review. It can take 2 weeks. Then the data collection can take 2 weeks. Data analysis can take 1 day. Report writing can take 3 days. So we have defined or estimated the time required to complete this. So the next step for constructing the Gantt chart. So we need to put all the activities in order. So what is the first thing that you are going to do? This we have to define. What will be you doing? You will be doing the next thing. What you will be doing after that? Okay. So make a note of all the dependencies. That is the situations where you can't do one thing until the another thing is started or finished. We have to define this, or we have to put in order in this step. And the next step is to draw the Gantt chart. So give a start date and end date to each of the activity. Okay, and which are depending upon the duration of activity and dependency of that activity. Draw it as like a graph format. on which the x-axis will be representing the date or time and the y-axis will be representing the activity. So this is a typical bar chart or a Gantt chart. So the here in this we can see the various number of activities. So in this there are suppose 8 activities. The first activity is the award of contract. So it will be starting for on this the x-axis. So you can see over here on this the x-axis it is the duration of month, and on the y-axis we can see the various activities. So first we can see that after awarding of the contract, the survey of the work can start. So it will be taking 1 month, then again it can take the next month. Like this, we can develop the bar chart or a typical Gantt chart. So from this we can also make a note that what is the total duration of the work, what is their interrelationship. Here we can see that the award of contract is only starting after is finished, then only we can start the survey work. After the survey work only then we can start the excavation work. After the excavation work or during the excavation we can also do the foundation and walls. So like this we can determine the interdependencies also. We can draw on the axis the activities on the x-axis. Also we can find out the total duration of the project. So in this it can be considered as the 9 months to construct a project. Now what are the advantages and the limitations of the Gantt chart? So first advantage is that it is very simple to draw and it can be understood very easily. Then good visual communications can be done with another also. Task durations can be compared very easily with each other. Then good for scheduling the resources also. So what are the limitations or the disadvantage of the Gantt chart? So first is dependencies are more difficult to visualize, and minor changes in data can cause a major change in the chart. So these are some of the limitations of the Gantt chart. So next we'll be seeing the network analysis. First of all, what is a network? A network is any system of interconnected linear features. So we can see these are the typical types of networks. Now, what is network analysis? Network analysis is a technique for planning and controlling large projects, such as construction work, research and development projects, computerization of systems, etc. Its primary aim is to program and monitor the progress of a project so that project is completed in the minimum time. In doing this, it pinpoints the parts of the project which are crucial or critical. It can also be used in allocating resources such as labor and equipment, and thus helps to make the total cost of a project minimum. So network analysis methods. So network analysis methods are a group of special analytical methods that are used in cases where it is necessary to analyze and optimize a network of interconnected and related elements that have some connection between one another. So what are the various basic network analysis methods? The first method is the critical path method, which we'll be learning in this lecture. The next method is the critical chain method. The next method is the PERT method, which is also known as the program evaluation and review technique. And the next method is the GERT method, that is graphical evaluation and review technique. And there are various methods for the analysis of the network. Now we'll be seeing the critical path method. So before that, we'll be seeing the various terms related to network analysis. So first is the work breakdown structure, which we have earlier seen in this lecture. So work breakdown structure is the breaking down the project into constituent activities such that each activity is clearly identifiable and manageable. Then what is the meaning of an activity? So this is a physically identifiable part of the project that consumes time and resources. It is represented by an arrow in AOA diagrams, that is activity on arrow diagrams. Events or node. These are the beginning or the end points of an activity. Event is a point in a time and does not consume any time or resources and is represented by a circle. Path. This is a continuous chain of activities from the beginning to the end of the project. So here we can see what are the nodes and activities. So this each circle is known as an node, and between any two nodes there is an activity. So what are the source and sync events? So source event is the starting event and the sync event is the ending node, or the source event is the starting node and the sync event is the end node. Next is the merge and burst event. So wherein there can be situations wherein two or more activities merge. So in this 5, 6 and 4, 6 activity are merging at this node. So such type of event is known as merge event. So opposite to this can be the burst event. So wherein two activities are starting from a one node. So from this 8 node, there are two activities being starting at this point. So these were the merge and burst event. And what are the various type of activities? So activities are usually categorized into four types. So first one is the concurrent activities, activities that operate or occur at the same time. Predecessors activities, activities that must be completed before the activity can start. Next is the successor activities, activities can start when the activity is being completed. Next is the dummy activity, it indicates only precedence relationship and does not require any time or effort. The next type of activity can be the concurrent activity, wherein one or more activities can start or end simultaneously. We have seen this over here. Then the predecessors and successors activities. Activities performed before given events are known as the predecessor activities, and activities performed after the given events are known as the successor events. So here we can see the example of this. A must finish this activity. A must finish before B and C can start. So A is the predecessor of the C and B activities. Then we can see that both D and E must finish before F. So D and E are the predecessors of the F activities, and F is the successor of D and E activities. And there is a condition that both A and B must finish before either C and D can start. Next thing is the dummy activity. An imaginary activity which does not consume any resource and time is called a dummy activity. So dummy activity are simply used to represent a connection or relation between two events in order to maintain the logic in the network. So it is represented by a dotted line in the network. So here we can see the dummy activity over here. So both A must finish before B or C can start. This is the condition. So C must finish before D can start. C and B must finish before F can start. So here is this condition that C and B must finish this C activity and B activity can finish before F can start. And in this we cannot make for any two activities the same starting point and end point. So logically, if we are going, it would have been like this, that this would have been a activity C and this had been activity B. So C and B must finish before F can start. So this would have been this condition. But there is condition that no two activities can have the same start point and end point. So to avoid this, what we have done, we have created a dummy activity or a node over there, and then we can connect this. So this is the dummy activity over here. So error must be avoided in constructing a network. So two activities starting from a tail event must not have the same event to ensure that it is absolutely necessary to introduce a dummy activity as shown in figure. So looping error should not be formed in network as it represents the performance of activities repeatedly in a cyclic manner. So in a network, there should be only one start and one ending event. So the direction of the arrow should be flow should be from left to right, avoiding the mixing of the direction. The next thing is we'll be seeing is the critical path method. So what is a critical path we'll be seeing first? The sequence of project activities which add up to the longest overall duration, or the critical path determines the shortest time possible to complete the project. So what is critical path method? The critical path method is basically a step-by-step project management technique that separates planning and scheduling. It also clarifies interrelationship of time and cost. CPM, that is critical path method, evaluates all possible alternative plans for project and associates each plan with a schedule. So also it is a mathematical based algorithm for scheduling a set of project activities. So the origins of CPM will be seeing. The CPM was developed, that is the critical path method was developed in 1950s by Morgan Walker of DuPont Chemical Company and James Kelly Jr. of Remington and which was a machines manufacturer. It was first used in missile defense construction project. Since that time, the critical path method has been adopted to other fields, including hardware, software, product research and development. Now, where it is used now, it can be used for software development, it can be used in construction work, it can be used for aerospace and defense, it can be used for research project, it can be used for product development and many more reasons. So why it is important? So according to Dr. Larry Bennett, the critical path method also has the three main benefits for project managers. So which are, it identifies the most important task or the critical task. It helps to reduce the timelines with the mean help of crashing. It also compares planned progress or planned activity with the actual activity, or the planned work with the actual completed work. So there are 6 key steps for the critical path method, which are, the first step is to specify each activity, then establish dependencies, that is activity sequence, then we need to draw the network diagram, then we need to estimate the completion time, we need to identify the critical path, then we need to update the critical path diagram to show the progress. So let us see them one by one. The first step is to specify each activity. If first step is to identify the main deliverables of a project, then we can start breaking down the high level activities into smaller chunks of work. So suppose this is an work, so we are dividing this work into task and into task, then again this task can be divided into 2 subtasks, then again this can be divided into work packages. So this is the first step which we need to do. Then we need to establish the dependencies, that is activity sequence. So some activities will depend upon the completion of others. So listing the immediate predecessors of each activity will help us to identify the correct order. Now after finishing this, we need to draw the diagram in this way. So once we have identified the activities and the dependencies and interrelationships, we can draw the critical path analysis chart known as the network diagram. So this is a typical network diagram using critical path method. Then we need to estimate activity completion time. Using past experience or the knowledge of an experienced team member, you must know the estimate time required to complete each activity. This is the most important step. If you are managing a smaller project, you will be most likely estimate in days. If you are working with a complex project, you may have to measure time in weeks. Then we need to identify the critical path. So first of all, we'll be doing the interrelationship with activities, then we can define the time estimates, then we need to identify the critical path. So how to identify this critical path? So there are two ways to identify the critical path. So first method is that you can eyeball your network and simply identify the longest method. So this is throughout the network. So this is the first method, and the second method is that you can also identify the critical activities with the forward pass or backward pass technique. So identifying the earliest start and finish times and the latest start and the finishing times for each activity. This can be the another method, that is by time calculations we can also identify the critical path. And the next step is to update the critical path to show the progress. As the project progresses, you'll learn the actual activity completion times. The network diagram can then be updated to include this information. So how to do the calculations of the critical path method? So we need to find the following of the each activity, that is the earliest starting time, earliest finish time, latest start time, latest finish time. The longest path of the planned activities is the critical activity. Then with the term, after doing this, we can see that float, it is the amount of the time of an activity which can be delayed without delaying the project, that is known as the float or slack. And the critical activity, the activity with zero float is known as the critical activity. So what are the advantages and disadvantages of critical path method? So provides the consistent framework for planning, scheduling, monitoring, and controlling project. It helps proper communications between departments and functions. It determines expected project completion date. It determines the date on which the task may be started or must be started if the project is to be stay in schedule, or which doesn't have to be delayed. It shows which task must be coordinated to avoid the resource or timing conflicts. It also shows which task may run in parallel to meet the project completion date. So these are the advantages, and this is the information we can take from the critical path method. What are the disadvantages? So reliability of CPM, that is critical path method, largely based on accurate estimates and assumptions made. So time estimates are very much important in this. If they go wrong, then it might not be the successful project. So CPM does not guarantee the success of project. Resources may not be as flexible as management hopes when they come to address the network float. Too many activities make the network diagram to be complicated. Activities might themselves have to be broken into mini projects. So these are some of the disadvantages of the critical path method. I hope all of you have understood this. Thank you very much.